Okay, good afternoon, everyone. School 2, can you hear me? Hi, good afternoon, everybody. I cannot hear you. Okay, great. I can see you. So, today we are revising a chapter that is triangles. Now, today's lecture will be a little bit theoretical, but it will help you in attempting your examination. So, be attentive, and I'll be taking your help at every step. Every single step, you have to help me, right? So let's start. Now you all know me. My name is Dilpreet Kaur and I am your maths teacher and we are moving forward. So here, triangles complete revision we are doing today. So what will we learn in today's class? That is introduction of triangles. That is the basic definitions or what are the properties of triangles. We are learning that thing. And after that, in properties, exactly the properties we are dealing with the congruency. We are dealing with the congruency of triangles. I hope you understand some terms from these, what I have speak right now. So we'll be doing the next part, that is introduction of triangles. Now let's start. So you have to help me here. You know that triangle is made up of two words, right? They are made up of two words. And the first word is try. That means, do you know the meaning of try? Yes, what is the meaning? It is three, right? It's very easy. It is three. So try means three. Now angle means, you know what is angle? Angle is this thing, this thing. Okay, so this is the angle, right? Now we are talking about three angles and it is a polygon also. So we have to just join this and we get three angles and this is a polygon and hence it is a triangle. Isn't that simple? So triangle definition or any word, if you want to understand that word, you have to separate it. You have to separate that word. Now in triangle, we have tri, that means something, and we have angle, that means something, right? Now you can also say that, ma'am, in polygons, and if we are talking about triangle, we have three sides, right? So we have three sides also. Now you know the basic geometrical figure, that is triangle. Now I understand that you know about triangle. So can you give me some examples from your day-to-day life where you can see triangles? Anyone can raise your hand and just answer me. Girls, kindly focus. Okay, I can see you talking to each other only. Kindly talk to me. So you have to give me some examples that looks like triangle shape or triangular shape in your day-to-day life. So any examples, anyone? Don't be shy. It's only me or you all. You all know each other. You all know me. So kindly give me something. I want to compare that. What am I thinking and what are your examples? Everybody's pushing like you say, you say. Kindly, kindly stand up and tell me anyone. Okay, so I'll be calling out someone. Okay, let's again do that activity that I'll be calling from boys. Boy number 2, comma 2. Kindly stand up. Second row, second column. Yes. Now you have to come. So, do you know anything or place that looks like triangle?
Samosa, ma'am.
Samosa, right. When we are talking about samosa in 2D, that it is in the shape of triangle. So, why were you sitting there? Why don't you come earlier? You were imagining samosa and just like tasting it. Okay, you can sit down. I also like samosa. So now 2,2 from girls also. Kindly come forward. Let's see whose example is like more innovative. Yes. Sandwich. Okay, so we are talking about sandwich. Everybody's talking about only like food. Okay, you can sit down. Somebody else like 4,4 from boys. We are talking about sandwich. We have a 2D samosa.
Pizza piece, ma'am.
Pizza piece. Okay. So pizza. Okay, you can sit down again. 4,4 from girls. Let's have something else. Like without food, without considering food. Either you only know these examples or you all are hungry. Okay, there are no 4 rows. Okay, yes. The girl came.
Ma'am, set square, ma'am.
Set square. Great. She is learning mathematics. Everybody else is hungry only. Okay, you can sit down. Now, we have set squares. Anyone have any other example like not regarding food, anything else like something innovative? I know the answers are coming to your mind. That. So, you all like ice cream? Everyone? Yes or no? Raise your hands. Okay, you like, right? So we have ice cream cone. If we are talking about samosa in 2D, then we can also consider the cone, right? The ice cream cone is also in the shape of a triangle, right? Now, if you have umbrella and the top of umbrella, if it is designed like this, it is designed like this. So it contains so many triangles in that design, right? Okay. So if we have a boat, if we have and we have a cloth on that boat that helps the boat to sail, right? That is also in the shape of triangle. Or we can say some flags when we see on the streets that also looks like triangles. Okay. Are some examples which we can say look like triangles. So, school one, do you have any example that is the example of triangles in your daily routine, in your day-to-day life? Anything we have already? We already have samosa, sandwich, pizza. Any other examples like leaving all these? Which one?
Nose, ma'am.
Again? Can you say again?
Nose, ma'am.
Nose.
Yes, ma'am.
Oh, nose, right. It is also in the shape of a triangle. Okay, great. This one is innovative. I cannot think of nose. Okay, so nose is also in the shape of triangle. So school one, if I call school one, kindly look at the screen and kindly answer the question. Okay, so girl number 2,2, kindly stand up and give me some example that looks like triangle. Okay, anything that looks like triangle? Can you think of anything? You're saying ice cream. Ice cream doesn't look like triangle. The ice cream cone looks like triangle. You are thinking of any example? Samosa. Okay, samosa is the answer. There are very like samosa loving people here. Okay, you can sit down. You can sit down. Okay. Yes, somebody is saying from school too. Yes.
Ma'am, mountain, ma'am.
Mountain, great. I love mountain. So mountain is an example. Full one, you are making so much noise. Okay. So we have mountain, we can say pyramid from one side. If we can say pyramid from one side, that is also in the shape of triangle. So everybody quiet. Now we have a lot of examples regarding triangles. Now let's try to study what is in the triangle, right? What are the components of triangles? We have flag, sandwich, set squares, umbrella design, pizza, and cone, nose, mountain, pyramid. We have so many examples. So, which means we are surrounded by all these shapes, all these geometrical shapes, right? So, what we have here, a triangle that is ABC. Now, let's see what are the components of this triangle. Now, in the introduction of triangles, we are having some angles. As you can see here, this is angle A, angle B, or angle C, we can say. Or we can say this angle A as angle BAC. Now, this and this are same. Angle A and angle BAC are same. Angle B and angle ABC are same. Angle C and angle BCA are same. You know that center one is the vertex where angle is forming. So we are having three angles because the name of the figure is triangle, right? It means three angles. Now let's move further and let's see vertices. Now can you tell me how many vertices a triangle has? There are three vertices which are A, comma B, comma C. So we are having three vertices here. Let's move. Now we are having some sides. How many sides a triangle has? Three. So we are having three sides that are AB, BC and CA. And you can also spell them like BA, CB or AC, right? It doesn't matter. So there are three sides, three vertices and three angles. Now let's talk about the name of the triangle. Name of the triangle looks like this with the triangle sign, and we have triangle ABC, or we can say triangle BCA, or we can say triangle CAB. So there are so many names of one single triangle. Okay, there are so many names of one single triangle. I hope you understood that how the components of triangles looks like. Angles, vertices, we have sides, we have name of the triangle. Everybody got this? School 1, school 2?
Yes, ma'am.
So today, school 1 is has joined late. So today we are revising the triangles chapter. Okay. So we will be introducing triangles. We will learn about some properties or components of triangles, and then we will step on to congruency of triangles. Right. Now let's move. What we have some classification. Now, what does classification mean? We have classified or divided the triangles into three types. So here, triangles based on sides. Do you know some triangles which are classified based on sides? Okay, let me give you a hint. On the base of side means a triangle which has all the sides equal. What is the name? It's an equilateral triangle, right? So first triangle I am talking about, that it is equilateral triangle. And all the three sides are equal, right? Now, when I am talking about only two sides are equal, the name of the triangle where only two sides are equal. Okay, can you speak aloud or somebody just come near the camera? It is isosceles triangle. It is isosceles triangle. Everybody know this name? Yes or no? Okay. So girls of school 1 and 2 both are like not performing or not indulging with the lecture. So do you understand everything till now?
Yes,
Kindly participate. I only know with your yes or no or with your hand raising only because I cannot see you properly. So you just have to answer the questions. That's why I got to know that you are understanding. Okay, understood?
madam.
So boys are performing really well from both the schools, but girls are not performing. Okay. Now we have equilateral triangle. We have isosceles triangle. Now what will be the third type? It will be that none of the sides are equal. So what is the name? Anybody know the name of a triangle where all the sides are unequal? Okay, I guess nobody knows, right?
I just carrot.
It is scalene triangle. It is scalene triangle. See, here all the three sides are equal. Here only two sides are equal. Here no side it is equal. No side is equal. Okay. So these are the three types of triangles which are classified based on sides. Based on sides. Okay, so where three sides are equal, what is the name? Everybody. Where two sides are equal, what is the name? Where no side is equal, what is the name? Triangle. So these are the three types of triangles based on sides. Now let's look at some angles. Triangles based on angles, right? Now let me ask you something. Okay, so we have here also we have some triangles. Now we can say that we have acute angle triangle. We have acute angle triangle. Or we can say right angle triangle, right? We have right angle triangle. So here in acute angle triangle, all the angles are less than 90 degree. All the angles are less than 90 degree. All angles are less than 90 degree. Here, one angle, it is equal to 90 degree. And here, the last one, I can say that is obtuse angle triangle. That is in the shape of like this. It will look like this. So one angle is more than 90 degree, right? One angle is more than 90 degree. Now we can also give some name that equilateral triangle also in this classification. It can also lie in this classification where all the angles are equal and that is equal to 60 degree. Everybody know this thing? In equilateral triangle, what is the measure of angle? It is 60 degree, right? So we have this thing also. So there are like so many properties here. Triangles based on angles, I can see acute angle triangle where all the angles are less than 90 degree, and this equilateral triangles also lie in this category where all the angles are less than 90 degree. Right angle triangles look like this. It has one angle equals to 90 degree and other angles are less than 90 degree. And obtuse angle triangle looks like this, where one angle is like so big than 90 degree, it looks like this. So I hope you understood that how we classify the triangles based on angles. Now let's move further. We have this diagram. So what I am telling you here, altitudes of a triangle. So try to revise everything, guys. This is a lecture that will make you revise this chapter. So maybe after attending this lecture, you just have to go through it only once, only while practicing some questions. Otherwise, your theory part will be done. Okay, your theory part will be done. So what are altitudes? We have this point that is A. From A, we can draw altitude on the opposite side that is BC. And this will look like this, 90 degree. And from B point also, we can draw altitude on CA. And that will look like this. And from C point on AB, we can draw altitude like this. Altitudes are that are side that is drawn on the opposite side and the angle is 90 degree. And the angle is 90 degree. So these are the altitudes of a triangle, right? Now, do you know that what is the center? If all these altitudes meet at one single point, What is the name of that point? Do anyone know? O is the name. Like, what is the name exactly? Like, what does this point named as? It is circumcenter. It is circumcenter. Oh, it is orthocenter. So it is orthocenter. Orthocenter is the point, that is the center, that is the joining point of all the altitudes, You can write this. Orthocenter is the point where all altitudes join each other. Right? So I hope you understand. Now moving on to the next one. What we are having here is, that is medians. What we are having here is medians of triangle. So in median, what we can see, medians are the line from the opposite vertex on the opposite side which bisect that side. So let me draw you the figure. So we have this triangle. From A, we can draw a line like this on BC, and that will bisect BC. So we can say that AD is bisecting BC. Everybody understand this? So we have this as AD as the median of this triangle. But the triangle has only one median. Do triangles have only one median? No. We can also draw medians from other vertices. See, I can draw a median from B to AC. Here it is bisecting the opposite side. And we can also draw from C to AB like this. Here also it is bisecting the opposite side. So it is BE, it is CF, right? Now, this point where all the medians are intersecting, it is known as centroid of the circle. Where all the medians of the triangle are intersecting. So everybody is getting this point? Everyone sure? So circumcenter, which I said earlier, circumcenter is the intersection point of perpendicular bisectors, which is the combination of orthocenter and the centroid. See, here we only have the opposite side is getting bisected, and in the previous one it has right angle triangle. When we have a triangle where the vertex here A, and we are drawing like this, it is bisecting also and it is perpendicular also. Then the point where all these perpendicular bisectors are meeting, this point, it is known as circumcenter. You can note it down: orthocenter, centroid, and circumcenter, right? So we have all these as the properties of a triangle. Now you will be thinking where this circumcenter centroid will be getting used, right? But in some questions, in some advanced questions, it is directly said that G is the centroid of the triangle. Then you have to revise it. What is centroid? Centroid is the intersecting point of all the medians. Circumcenter is the intersecting point of all the perpendicular bisectors. Orthocenter is the intersecting point of all the altitudes. Understood, everyone? Little theoretical. Everyone is understanding this? Okay, great. So moving ahead. Now the main part of the question is congruency of triangles. Now I hope you have figured out some congruent figures. Now If you have your passport size photos, everyone used to click our passport size photos. Every photo we can place over each other and they are identical, right? Because it is of the same person. It is of the same person. So suppose we have a person named Ajay and we have his passport size photographs. If I overlap these two, will you be able to identify that that is the same picture or there are two pictures? Will you be able to identify? Because it is exactly overlapping each other. Exactly overlapping each other. So they are congruent. They are congruent to each other. Is the side, the shape, the size of that picture is exactly same. Do you understand the concept of congruency? Okay. You have a pencil, a new pencil, right, of Natraj. So you have two pencils that is of Natraj company, and both are equal in size and equal in shape. So you can say that these pencils are congruent figures. Pencils are congruent figures. Is that understood? Everyone, are you sure? You have same type of notebooks that is of classmate, right? So you can take those two notebooks and you can compare them. The size, the shape of those classmate notebooks are exactly same. We can say that these two notebooks are congruent to each other. We can say that these two notebooks are congruent to each other. Now, can you tell me any more examples like of congruent figures? I have given you many, right? Anyone can think of congruent figures? You have to help me. I can think of only three examples. Coins, great. Somebody said coins. So all the 1 rupee coins are into each other. All the 2 rupee coins are congruent to each other. All the 5 rupee coins are congruent to each other. In the similar way, we have all the money in terms of notes also, coins and notes. Great, great. Whosoever has told me. Anything else? Anyone? In your house, when somebody came, you always used to, your mom used to cook tea or coffee, right? And we have all that identical mugs. We have all the identical mugs at our home, which are congruent to each other. So all the glasses or the mugs you are having at your house, identical to each other, right? Everyone, do you understand everything?
Twins, ma'am.
Twins, right? Twins. Great. Or you can say earrings. We have a pair of earrings which are identical to each other, right? Let's move further on the congruency of triangles. Now, what is the definition of congruency of triangle? In triangle ABC, if we have two triangles, triangle ABC and right? Sorry. We have two triangles, triangle ABC and triangle QR. The corresponding sides are congruent and the corresponding angles are congruent, then we can say the triangles are congruent. See, what I was talking about, we have this side AB. I have this side as PQ. Suppose AB is congruent to PQ, right? And this BC is congruent to QR. And this AC is congruent to PR. If all the sides are congruent, all the angles are congruent to each other with the two triangles, we can say that these two triangles are congruent. We can say that these two triangles are congruent. So if and only if the sides and the angles are congruent, we can say that these triangles are congruent. Right? Everybody understood? Yes or no? No energy. Okay, girls, do you understand? Okay, great. Okay, let's move on to the next part. Let's move on to the next part. So, I have another definition. We have a definition that says two triangles are equivalent even only if their corresponding sides and corresponding angles are exactly same. So, these both are like vice versa of each other. We can say this or we can say this, right? Triangle ABC and PQR corresponding sides and corresponding angles are congruent, then we can say the triangles are congruent. If the triangles are congruent, then the sides and the angles are exactly same, right? So now we will be learning about the different congruency conditions. Now we'll be learning about the different congruency conditions. Let's start. Now, congruency of triangles. Have you studied about these congruency rules? Have you studied about these congruency rules? Anyone? Yes or no? Raise your hand. Okay. So, this chapter is coming in your examination, right? Okay. So let me just give you some basic understanding of these congruency. Now, congruency of triangle, what we can see here, SAS congruence rule. So everybody be attentive here if you do not know what is SAS, right? If you do not know what is SAS, kindly listen to me. So this SAS, this is abbreviation. This is abbreviation or we can say short form. Short form of, let me write SAS. That says side, angle, and side. Now, what is the definition? Two triangles are congruent if two sides and the included angle of one triangle is equal to the two sides and the included angle of other triangle. If they are equal, we can say that these two triangles are congruent. See, I'm giving you example. I have ABC and PQR like this. ABC, PQR like this. If I have this equal to this and this equal to this and this angle equal to this angle, right? Now, with the help of SAS congruency rule, we can say that triangle ABC is congruent to triangle PQR. Okay, now SAS means side, angle, side, right? SAM means side, angle, side. So do you understand what is the theory? What is the theory? What is the definition is trying to say? If two sides of one triangle are equal to two sides of other triangle and with the included angle, then we can say that two triangles are congruent based on SAS congruency rule. So do you understand school 1, school 2? Little bit at least. What is the definition? What is the full form? In one question, I'll be like teaching you how SAS is being used. Okay. Now we have a question this. Are you able to see the question? Okay. Are you able to see the figure? I was asking that thing. So we have this figure and we have this question. Now let's understand what is the question is asking us and what is the diagram. In the given figure, AB and CD are intersecting. Let me change the pen. Okay. AB and CD are intersecting at O. As you can see, this is AB, this long segment, and this is CD. It is intersecting at O point, right? OA is equal to OB. OA is equal to OB. This single line states that these two sides are equal. OD is equal to OC. OD is this and OC is this, right? Now we need to show that these two triangles are equal. Now, just think, we have to use SAS, okay? We have two sides which are equal in both the triangles. Consider this triangle and this triangle. What could be the included angle? can you find the included angle between two sides? This is one side. This is one side. This is other side. What will be the included angle for this triangle? Kindly name the angle. Okay, nobody's answering. See, if I am saying I'm talking about this side and this side, what will be the included angle of this side? This is the angle. This is the angle I'm talking about. So here, what is the name of the angle we are talking about? It's angle COB, or we can say angle AOD, right? This angle we are talking about. Now, can you say that this angle and this angle are equal? Can you say that? You have learned about lines and angles and parallel lines. We have these two angles equal. Why? What is the name of that angle? It is vertically opposite. Do you remember anything? Vertically opposite angles? Yes or no, everyone? Okay, great. So I was just thinking that some of the basics are not clear, right? So here, what we can say now, we have to prove these two, right? What is given to us that OA, it is equal to OB. This is first side. This is first side. And we are talking about two angles. That is angle AOD. It is equal to angle BOC. That is because of vertically opposite angles, right? And we have another side, that is OD equal to OC. Again, one side. So we have side, angle, side. So we can say that just because of the previous statement that we have learned, we can say that triangle AOD is congruent to triangle BOC by SAS congruency criterion. We can say that with the help of these three, we can say that these two triangles are congruent. These two triangles are congruent. Do you understand why these two triangles are congruent? Are you sure? Okay. So these two triangles are congruent because of SAS. So I was just revising you this lecture because I suppose that you have already done this lecture, this chapter. Okay. So just try to listen everything very carefully because I have prepared for the revision. Now I am telling you one congruency condition and one example. Okay. So try to register it. Now then you will be able to do some more questions from your textbook. Now this question is done. The first part is done. Now, do you know that when two triangles are congruent, we have this statement? This one. When two triangles are congruent, all the other sides, the other angles which are remaining, all are equal. See, when the two triangles are congruent, all the remaining sides and the remaining angles all are equal. So we can do like this. We have this question. We need to prove that AD is parallel to BC. This AD, we have to prove that it is parallel to BC. Now, for the parallel thing, we need a transversal. Everybody know this thing? To prove two lines to be parallel, we need a transversal to act on the angles. See, we have some corresponding angles. We have alternating angles. We have vertically opposite angles. So these all angles only lie when we have two parallel lines and one transversal. Right? So when we have parallel lines, we can say those angles are equal. Or when we have those angles equal, we can say the lines are parallel. Right? So now, with the help of CPCT, now let me tell you what is CPCT. It is corresponding parts of congruent triangles. Corresponding parts of congruent triangles. That means if two triangles are congruent, the other sides and the angles are equal. So if we have this angle equal, this side equal, we can say This angle is also equal. Let me mark with red pen. See, this angle is also equal with the help of CPCT, because all the remaining angles will be equal to the other triangle. So we can say angle BCO, it is equal to angle ADO by CPCT. So with the help of these two angles, that is this, these angles are known as alternate interior angles. And these angles are only equal when the sides are parallel. These are only equal when the sides are parallel. So we have these angles equal. Now we can say that AD is parallel to BC. AD is parallel to BC. So I hope somebody understands something. Yes or no? Because I am just wondering that everything is going like this. So kindly tell me that you are understanding something, that it will help you. Yes or no? Okay, so that's what I am saying. Just try to understand whatever I am saying. And you can ask as many as doubts here. Here, I am just giving you SAS, that is side angle side, and one example based on this, right? Now let's move on to the next congruency condition and try to solve one question. Okay, now the next congruency condition is angle side angle. So try to listen. ASA. In the previous question, we were finding two sides and middle angle, right? Here, we are wanting two angles like this and the middle side. Two angles and the middle side. Now try to read this. Try to read this. Two triangles are congruent if the angles and the included side of one triangle are equal to two angles and the included side of the other triangle. I am drawing here two triangles A, B, C, P, Q, R. Now it is given to us that this angle is equal to this angle. This angle is equal to this angle. And BC is equal to QR. Now, if these three conditions are given, we can easily say that these two triangles are congruent because of angle side angle. We can see a property that angle of one triangle is equal to the other angle of other triangle, side and angle. So it is a system. We have to follow angle side angle, right? Angle side angle of one triangle is equal to angle side angle of other triangle. So we have this congruency condition. Now let's study that how this can be implied on a question. Everyone on the screen, no noise please. Now we have a question. Kindly see. We have to solve this by angle side angle. Now you have to try that what are the conditions given to us and what can we imply from these conditions. In the given figure, AL is parallel to DC. You can see that AL is this. It is parallel to DC, which means we have some angles equal. Now, if AB is parallel to DC, we can consider DL as the transversal. See, this is DC, this is AB, or we can say AL, this complete, and this will be acting as the transversal. Can you see that in the figure? Okay, so we can say that these two angles are equal as alternate interior angles, right? Okay, so we have to prove that EBL, which means this triangle, and ECD, that means this triangle. We need to prove this. Now, what is given to us? E is the midpoint of BC. That means this is equal. E is midpoint of BC. This is equal, right? So, we need to find some angles and sides so that this will be verified. Angle, side angle. This will be verified. Now, what we can do here? See, what we can do here? You can see that this angle is also equal to this angle. Now, this is also acting as transversal. Everyone, this is also acting as transversal. AL and CD are parallel. Okay? AL and CD are parallel, and these two angles are again alternate interior angles, because this CB is acting as transversal. Anyone can see this? AL and CD are parallel lines. CB is acting as transversal, so that these two angles are again alternate interior angles. Right. Now I'll name the angles. This is 1, this is 2. Now can I write angle 1 is equal to angle 2? Angle 1 is equal to angle 2 because of alternate interior angles, right? Now what we have EC is equal to EB. EC is equal to EB because E is the midpoint given already. E is midpoint of BC, which is given to us already. And the third angle should be this one. Third angle should be this one. What is the type of angle? This we have done in the previous question also. What is the type of angle here? Vertically opposite. Great. These angles, I am saying this is 3, this is 4. Angle 3, it is equal to angle 4 by vertically opposite angle. So can we say that these two triangles are congruent? Yes, because we have found one angle including side and the other angle. So we can say that triangle EBL is congruent to triangle ECD by angle side angle congruency criterion. Right? You understand, everyone? Only I can listen only one boy. Yes or no? Okay. Okay. Let's move on to the next congruency condition. That is SSS. Very simple. We just need to find 3 sides of one triangle equal to 3 sides of other triangle. Very simple. Two triangles, if 3 sides of one triangle are respectively equal to the corresponding 3 sides of another triangle, we can say that two triangles are congruent. We do not need any angle. Only 3 sides. Only 3 sides. Let me show you the question. So here we have ABCD. That is a quadrilateral, right? Quadrilateral ABCD, we have AB equal to CD. Let me mark it. AB, it is equal to CD, like this. And we have BC, it is equal to AD, right? Now in these two triangles, how can I equate the third side? Can anyone tell me? I have two sides equal. What about the third side? It is also equal. Why? Because it is common in between two triangles. AC, the diagonal, it is the part of this triangle also, and it is part of this triangle also. Everyone agrees? Girls? Okay. So we have one side this, second side this, and third one is already common. So common is equal, right? Common is equal. So we can say that AB it is equal to CD given to us in the question. BC it is equal to AD again given to us in the question, and AC equals to AC, that is common. Now we can say that triangle ABC is congruent to triangle CDA by SSS congruency criterion, right? It is easy, right? Only we have to find 3 sides. Only we have to find 3 sides. Everybody got the question? Are you sure? Okay, let's move on to the next one. We have RHS congruency rule. What does that say? RHS. That means we want one right angle. That is one angle. Second is hypotenuse. You all know what is hypotenuse. And the third is one side. Now, can you tell me from A, B, C, which side is hypotenuse? BC, right? The side opposite to the right angle triangle is the hypotenuse. Is the hypotenuse. Everybody agrees? So you have to figure out one right angle, one hypotenuse, and one the remaining side, any side, right? So let's jump on to the question. Now we have this question. Question says P is a point equidistant from two lines L and M. This is L, this is M. Now P is the point that is equidistant, which means this this distance, this distance, and this distance. How we manage the distance? This is a line, this is a point. How can we say what is the distance between point and the line? That will always be the perpendicular distance. Not this one, not this one. Okay. Always be the perpendicular distance. Do you understand this? Distance between one point and a line will always be the perpendicular distance between them. That is this dotted one. Now here it is said that P point is equidistant, which means at equal distance from two lines. That means PB, it is equal to CP, right? Understood, everyone? You can draw the diagram and you can see that how I told you that PB, it is equal to PC or CP. Because it is given to us. It is given to us equidistant. Equidistant. Now you all know that this distance is always perpendicular. This distance is always perpendicular. To B, it is equal to angle C, 90 degree. I have angle B equal to angle C. So we are using RH, right? Now R is done, S is done. What about hypotenuse? What is the side opposite to the right angle triangle? Tell me, what is the side? You can just draw the diagram like this. See, just make it little bigger. This is 90 degree. This is 90 degree. This is point P. This is B. This is A. This is C. Right? Now this is right angle triangle. What is the opposite side of right angle triangle? It is AP. Right? It is AP. And AP is common in both the triangles. Which means hypotenuse, that is AP, it is common in both the triangles. So we have our R, we have H, we have S. Correct? So we can say that triangle ACP is congruent to triangle ABP by RHS congruency condition. Right? Do you all agree? Everyone? I'm trying to make you understand, but I do not know that what is this. It's like I am giving out everything. So, RHS, that is right angle, hypotenuse, and one side. So, all these three things are equal to both the triangles. So, two triangles are congruent. We need to show that the line AP bisects the angle between them. So, I told you when two triangles are congruent, every other thing is equal. Every side, every angle. So, these two angles will be equal, right? These little two angles. I can show it here. These two angles will be equal because of CPCT, corresponding parts of congruent triangles. So these two angles, I am saying this is 1, this is 2. So angle 1, it is equal to angle 2 by CPCT. We can say that line AP bisects the angle between them, right? These two angles are equal. So we can say that line AP bisects the angle between them. So do you understand this question? Okay, you have the these notes you are having. So kindly revise it again. This triangle chapter is the basic chapter, and here quadrilateral is also based on triangles, and the areas chapter is also based on triangles. So triangle, if you have strong basics in the chapter triangles, every chapter, quadrilateral, every chapter will be easy for you because every chapter is using congruency conditions, right? So I hope everyone gets this. I'm hoping this. Kindly revise these all congruency conditions and we'll be meeting again in next lecture. So till then, all the best everyone. Do your test carefully and try to perform better, okay? Will you promise? Do you perform better in the test? Okay, great. Bye-bye.